Okay, I want to give a quick video run through on how I 3D print something. First, what I do is I start out in Autodesk 3D Design, and I'll edit a sketch. So I'll open something for my projects. Here I'll open eSig drip tips, and I'll leave a link available in the description below. And so now, as that's loading, I'll show you my 3D printer. So I also wanted to make this video as just a quick run through, first video of my 3D printer setup. This is what I call the Venumaker, and it'll be shortly up on Kickstarter. It utilizes a dual head 3D printer extruder. This I got off eBay from 3DP, Micron Industries. And the heat bed with aluminum on top, and I use a little bit of what you're going to call it, hairspray for a little adhesion. I'm utilizing Arduino Mega 2560 or 2650 with the Ramps 1.4 boards. And an issue I'm having is that I've gone through several power supplies. You can see I have two set up right now. This one is driving the Ramps board. You see this one is rated for 20 amps on each 12 volt line. There's two 12 volt lines, and I ensured that I got them both split properly, and you can hear the noise that this is making. So this is obviously not enough power, and there seems to be maybe a malfunction inside this one. This other power supply I was using, it wasn't strong enough, and it kept wigging out, so I had to get another one. Actually, I was using an initial power supply, but that one actually burnt out. One of the capacitors ended up blowing. It made a magnificent pop sound. So here I have two sketches I could print, but I only want to print the one on the right, so I'm going to go ahead and delete. Maybe I'll select this and delete this. Oops, sorry, let's get this in focus. That's a little bit better light. And then what I would do is I would go to the top left and just click 3D print. And what's going to happen, it's going to open the program Mesh Mixer. Let's get a good angle here. And I'll export this like so. And let's just name it drip 1 for now. I'll go save. And Mesh Mixer is giving me a little bit of trouble on this computer. I'm using Windows 64-bit. There's some issues, so I'm not going to use Mesh Mixer here. I'll just skip using Mesh Mixer altogether, and I'll open my STL file in Cura. Another problem I've been having with my 3D printer is the extruder. I guess it's kind of incorporated the same problem, the power and the extruder. I don't get enough juice, I guess, to the hot end, and in turn the prints aren't perfect yet, so I probably need a new power supply. I've been trying with Pronterface again and again with the M303 code for the PID settings test, but no luck. Okay, so I actually have the 3D printer hooked up here by USB, so I'm just going to save the file, save G code, and what I'll do is I'll save it to my SD card, like that. Now the problem I have with my 3D printer is the dual head is really heavy, and what Cura wants to do, it wants to raise the Z-axis 5 millimeters after it's done the print. So that doesn't work out because of the acceleration. It ends up making a grinding noise, and my next print ends up being off a little bit. So what I do, I go in here manually and I change this. It's 29, so that's 24, and after it's done printing I only have it raise 0.2, so it's 29.5, and at the end of the print I only let it raise to 24.7, so that's only 0.2 millimeters above the finished height. As you can see, I manipulated the encode a little bit after in Cura. I took out the G91 codes because I thought that was the issue. That was causing the grinding noises, but no, it turned out that it was trying to go up too high, too fast at the end of the print. So I'm going to save that to back to my SD card, and I'm finished with that. Let's just eject my SD card, and this is just about a temperature. So from here I'll print from SD. Good one, there it is. Okay, and I also been manipulating some of the PID settings, so I'm going to go back and make sure they're all saved properly. No, the PID-D didn't save properly, so I'm going to go to my PC because I had a bunch of different settings or different test runs. So the PID-D 68.08. Now I'm running Marlin firmware on this one. So someone had mentioned, or rather the PID control page on RepRap mentioned that you should multiply the PID-P, PID-I by a certain ratio for Marlin firmware, because Marlin is based on a different something or other. I don't quite understand that, so if someone knows anything about this, please clear it up. Okay, as I'm rotating this, I'll give you another tour around my 3D printer. So the y-axis is utilizing 10mm rods as well as the x-axis. The z-axis is using 12mm rods, and the drill rod I'm using is just 8M. The belt is 3mm pitch, 9mm wide belt. I got the pulleys as well as the holder here. I guess, what would you call this? The clamp. Yes, the clamp for the tooth belt from the same guys who made the extruder, and they were really nice enough to make the platform for me. So I designed the platform and corresponded a bit just to make sure the measurements were right, and they made me this beautiful platform. They actually were more than happy to do that for me. So thank you very much. I really appreciate you guys, and thanks for the advice on the PID settings, and also for letting me know that about my power supply, and I think in fact it is my power supply. So I'm going to try here anyways, just to show you guys what happens is it wigs out if let me just get this right here. 68 points, what is it? 68.08. It wigs out if I have the fan on. That's close enough. 68.0. Okay, so that should be just about ready to print. Let's see what the temperature is at. It's my screen has some issues here. I'm not sure if because I was twisting on the knob too fast or what happened, but it looks like my printer could use a reset, graphical reset there. Okay, well, I'm gonna fix this problem. I'm gonna cut here. I'll come back when things are kosher again. Thanks. Okay, I just did a power cycle and got everything back up and running, and I got my new PID settings, and we're just about at temperature. It seems to be getting a little bit slow for the hot end. I actually installed a new AC today, or rather last night, so maybe that's affecting the hot end heating up. Seems to be at 224. I hope it doesn't wig out at me here. I'm actually considering just unplugging the fan at the front. So if you can see, I've got a little fan at the back, which doesn't really affect the hot end as much as the one that comes stock on the extruder itself. The problem isn't the fan, now I realize it is the power supply. So Yeah, I had a fan up here on front to cool down over here. I thought that was the issue, but no, in fact, it's just my power supply just can't meet the standard there. You need a really good power supply for this extruder and this setup here. I also wanted to put a fan on this side. I made a bracket to put a movable fan to cool down the piece as it prints, but still can't add any more fans on there until I get a better power source. So this should be about a temperature, hoping, no, it's at 226. Okay, 225. So that's not looking good. What I'm going to do, because it's kind of cold in here, I'm just going to go ahead. I have this set up to the fan at the front. I'm just going to unplug that and leave that neatly there like that. And just let it print like this without the fan. But I have the fan at the back running. The extruder fan on the front isn't running. It cools down the heat sinks. If you can kind of get a glimpse of it in there. I also set up a nice LED array so brightly lights up the piece we're printing. Yeah, and it's off. So I'll get a better angle here. So this is the typical mess I work in. It's kind of cluttered right now, so I just wanted to give you guys a raw idea on what I'm doing. So this is really, garage or office space kind of project. And you can't really see the piece from here, so I'll go in. So I do not have that fan on at the front here. I really hope that it doesn't cause a jam or anything like that. I think my experience, the jams I've been getting are due to underheating as opposed to overheating. So I think this time around I'll be safe. And yeah, hopefully this goes through nice and easy. Seems like it's going pretty well so far. So again, this is a drip tip for an e-cig. I'll have a link in the description below for the schematics, the STL files. Okay, let's get another angle here, get the idea from here so far. Wow. So it's kind of hard to see what's going on unless it's unless it gets a little bit higher in the print. I really need a good webcam to set up somewhere. Just mounts it on the extruder, I think. There we go, that's a better shot. If we can focus. So this is what I need the fans on the outside for. If you can see the side that has the fan over here, this side seems to be going down a lot nicer and the other side is lifting a bit. So that's why I'd like the fan on the other side. Maybe I can get away with it without having the stock extruder fan on. That's an idea. I'll do that for my next video once I set that up shortly. Oops, I hope I didn't have my finger on the microphone. If I am, I apologize. I did that before. So you can see here my heat bed. I have a metal plate at the bottom and some cork in between so that there's not loss of heat on the bottom too much. Then I have the hot plate, the MK2B, I think, and then the aluminum bed on top. to focus on the piece there. Okay, as that's printing, I guess I can go over a few things. Some more with my printer. Here I have the rolls on top, just hooked up to a bar. Nothing's moving over there, but I could reposition it if necessary. Here I've 3D printed some brackets to hold the Z rods, and I have a little Guardian on top. The NEMA 17 motors, of course. They are the Kaizen type, 1124090. These work great. I'm really happy with it. You can see I have a thrust bearing underneath to support, well, prevent damage so much to the motor as the Z-axis is going up. And things are a little bit cluttered right now. I got 2 power supplies. I have this power supply powering the ramps board. I have the other power supply actually powering the external fans. I just have it lined up to the plugs in front of the extruder, and that fan back there is also powering the light. What else about this 3D printer? So this is an entirely custom design. It's 1010 aluminum extrusion from 8020. Really good company. I got the ramps board and the rest of the electronics on eBay, as well as the bearings and rods and stuff. Most of the stuff I'll be getting a direct supplier as opposed to from eBay. For instance, the bearings and the rods I'll be getting from Ontario. The aluminum extrusion, I'll be getting it from 8020, and they'll be cut at locally at their local distributor. Yeah, I need to put together a list of where I'm getting this stuff so that I could post this online, because I'd like to share that with you guys. Because it's really important for me to get all this stuff together so I can get this project going. Oh, also I wanted to mention the idea for the design I got was the Henkel from Helco. I think it's, oh shoot now, Helco from RepRap. Anyways, I'll put the link in the description below also if you want to try building your own. But I thought I'd make it easy for everyone and start distributing this for a low price. I'm trying to shoot for a price point of $2,000. So if you guys are listening, pay close attention. I'll be kickstarting soon, I hope. If you guys have any suggestions, please let me know. I appreciate any input, any insight is great. You know, even people who aren't new to the scene, like there's no reason why you guys can't comment or have some, give some insight of your own. So that's really cool stuff. Let me get back in here. It's just about done. It seems. Yeah, it looks like the dark side of the moon on this side, so I'm going to go over here again. And we'll focus. Well, that's looking pretty good. A lot of good adhesion there. I used, I think, 6-7 ring brim. And I haven't changed that hairspray for maybe 20 prints. 20 prints I've been printing on that hairspray. I have been moving around the heat bed, as you see I did on Cura. But, that's where you get more use out of it. And so, I guess I'll grab the piece that I designed this after. It's a drip tip for an e-cig. It's $4.99 and it fits into my Acer Aspire very nicely. However, it got dropped on the floor by someone and it broke, so I had to 3D print another one. But in that time that I had my 3D printed one, I managed to super glue my original one back together. So, to show you, I have a 3D printed case for my Acer Aspire. Acer Aspire. Aspire, not a list. I've been saying Acer Aspire. Ha! Too much computers. So that's that. And I have a little grip here, which is also acts like a roll preventer. I designed these two also the same way as you saw. I was using 123D Design by Autodesk, and then Mesh Mixer, and then Cura. So that's the general process how we do these things. So as you can see, I had some funny stuff happen on this side of the cover. It didn't go so well, so that's why I put the fan up there. That was before I had the fan on the side of the extruder to cool down the piece. So let's go back to the piece because I'm sure it's just about to finish here. Get this camera to hold steady. There you go. Beautiful. And there we have it. Let's try and peel this thing off. This is supposedly still 80 degrees. So, what I do, I go over and grab my stencil tool. And get a little focus in there. There we go. Just get underneath. Oh, okay. That worked, didn't it? Alright. Great. Thanks for watching. And I hope you enjoyed. Have a nice day. Okay, I suppose you wanted to see how it fits once I have it all cleaned up. So I took the flashing off just by hand, and it fits in really nicely. I don't even need the rubber stopper on there. Bam. Then we have a beautiful new end drip tip.